So today I want to talk about the EPA regulations for 2007. There had been EPA regulations in 2002 and back in 1988, and the whole process was reducing the amount of emissions coming from these diesel engines. Now the SO, the sulfur, was dealt with. When we went down to ultra low sulfur at 0.15%, and there's a parts per million, very small parts per million of this sulfur, so it's reduced almost to nothing, and that solved the sulfur problem. But that still left us the carbon dioxide, the NOx, and the particulate matters. And specifically towards diesel engines, this was a bit of a problem. So in 2002, the EPA made regulations that they have to cut the NOx and the particulate matters by 50%. And this was done through the EGR process. So the EGR process reduced the NOx by having the diesel engine not, when it was working normally under normal load, it would put exhaust gases, cooled exhaust gases into the combustion chamber, reducing NOx. Again, reducing the temperature of the cylinder and within the cylinder, and that created more carbon monoxide and more particulate matter. So in 2007, in 2002 that was within regulations, but in 2007 EPA came out and said 90%. On an earlier video I said 80, but it was actually 90% reduction in particulate matter, which was shocking because you could not get an engine to put out less particulate matter even with using the EGR technology. So what they had to do is come up with an after treatment system. So the exhaust, the big exhaust muffler, was removed and a new component was added. And it looked a lot like a muffler. They designed them to look like mufflers. They live on the stacks of trucks or underneath a vehicle. But this system was put in. And what it was called the DOC and the DPF. DOC is a diesel oxidization catalyst, and the DPF is diesel particulate filter. So what was essentially inside this is little tiny tubes, and it was made of a stone material, and they're very, very tiny, and all the exhaust had to come from the engine and flow through this DOC. The DOC had to be as close to the engine as possible because it used the heat inside here to produce a catalytic process. And this catalytic process, or a catalytic process, basically uses a type of metal that's inside the DOC that causes the atomic structure of the emissions to change at a lower temperature than it would normally take. So I think it's 1200 degrees to get carbon monoxide to split and turn into carbon dioxide in water, but this could do it in half the temperature. So this catalytic process made it so under lower temperatures we could turn the carbon monoxide and basically the carbon monoxide and take it so it would turn into carbon dioxide. Now, coming out of a diesel engine is a lot of oxygen, a lot of carbon monoxide, and a lot of particulate matter at this point. So the oxygen fueled the diesel oxidation catalyst and combined it with the CO, and that cracked the carbon monoxide, turned it into carbon dioxide, which is harmless. And that was what would go through the DOC. Now, the DPF, which was attached to the DOC, right behind it, had the same type of tubes going through. But in these tubes, they ended. So the exhaust would go through, the carbon monoxide through a catalytic process was being turned into carbon dioxide, and then particulate matter would flow right through into this, and it would have to go through these tubes that ended, so they couldn't get out. So the particulate matter would go through and get caught up in all these tubes. So now you've turned your carbon dioxide into carbon dioxide, the particulate matter has gone into these tubes and is not going out the exhaust, and it solved the problem. However, these tubes started to get plugged up with the particulate matter. Now, because of the heat and the oxygen, basically there was a passive regeneration, which basically meant all this particulate matter was actually starting on fire, burning up, and turning into ash. And that small ash would plug it up eventually, but it would take quite a while. So that was called a passive regeneration, and that would happen while you're driving down the road. if there was too much particulate matter, it would start to plug this thing up. And there were sensors all over these to tell the intake air to the outtake air, and if it became plugged, it would have to do a regeneration. And that could be an active regeneration as well. And what this required was fuel to go into, and the fuel could come through, depending on the fuel system. They would put fuel through the DOC into the DPF, and it would start to burn, and it would get very hot. Now there was different levels. I think there's 3 levels of active regeneration, and sometimes it required the truck actually to pull over on the side of the road, and the computer would take over regeneration to basically start an oven, start a fire in this furnace, and burn all this particulate matter into ash. Once the airflow through here increased and the computer recognized that it was not plugged up and it was just ash, then the vehicle could continue on. But a lot of these vehicles just used passive regeneration, which meant it burned up as it went through. Active regeneration was there if it got too plugged, and it met the 90%. So using the EGR technology to bring the levels down or the temperatures down, and then creating more carbon monoxide and particulate matter, which carbon monoxide got converted here, and the particulate matter got converted here, basically to carbon dioxide once again, and nitrogen, like in our air. That's what happened to the soot. So now it came out clean. So they solved the 2007 problem of 90% reduction in carbon monoxide and particulate levels through this DOC and DPF. I hope you found this helpful.